Let's work through an example using zip. First of all, some details about the built-in zip function. It returns an iterator over co-index tuples. So, if you had a list of 1, 2 and a list of 3, 4 and zipped them together, you'd get 1, 3, that co-indexed pair, and 2, 4, that co-indexed pair. If one iterable in the original input is longer than the other, zip only iterates over matches and skips the extras. So 1, 2 zipped with 3, 4, 5 gives you the same result. The 5 is lost. You can even zip together more than 2 iterables. 1, 2, 3, 4, 5, and 6, 7 gives you triples. One from here, one from here, one from here, all co-indexed. Okay, let's work on a problem together. Implement the palindrome function, which returns whether its input S is the same forward and backward, meaning that if you read the sequence S backwards, you get elements that are equal to the elements you would have had reading it forward. So 31413 is a palindrome 31413, but 31415 is not, because 3 isn't equal to 5. And we'd like this to work not just on lists, but on any kind of sequence. So here's the title of a book I like, which happens to be a palindrome, though not if you add a space in it. Alright, how would we implement this? You might think it's as simple as returning whether S is equal to what you get when you reverse S. And if we try this out, we'll find that the tests don't pass. Instead, this always returns false. Why is that? Well, if I have a list 1, 2, 3, and I reverse it, I get a list reverse iterator object. This thing is not equal to 3, 2, 1. It's an iterator over those values. I could try to get those values out by calling list, though I have to be careful. Doing it twice will leave me with an empty list, because once you go through the elements in reverse order, you've used up the iterator t. But one way to solve this problem is to build a list out of S, build a list out of the reversed elements of S, and then use list comparison in order to tell whether they have the same elements or not, meaning equal elements. Okay, so that passes the tests. But here's a second way. We could start with our list and zip it with a reversed version of itself. That gives me co-index pairs of 1 and 3, 2 and 2, and 3 and 1. If this were a palindrome, all of these would be equal. So we can write a list comprehension that computes whether each one of these is equal and see if they're all true. All A equals B for A comma B in the result of zipping together S and S in reverse. And that works too. Which one's better? I think they're both fine. The nice thing about this version is that it allows you to generalize the way in which you're comparing two elements. Right now we're using equality, but if we wanted to make sure they were close together or were the same after lowercasing or something like that, it would be easy to extend this version of the program.